Hello everyone, this is Mr. Slamka, and today what I wanted to talk to you about was I actually wanted to talk to you about the surface area of prisms and pyramids. So now if you're asking yourself, well, which section of the book is that, Mr. Slamka? It's not very clearly identified in the book. What we've done is we've taken a couple of ideas and brought them all together, so if you're looking for a particular section number, you won't be able to find it. But these ideas are presented in Chapter 11. So you can find all the information, it just won't be organized in the same way that we're presenting it here. We've done that in order to help you. So I think that this is going to be the best way, and so does your geometry teacher. So let's talk about surface area. So in the last set of videos you saw a net. And a net is a fantastic and great way of relating a two-dimensional figure and a three-dimensional figure. And today what we're going to do is we're going to talk about surface area, which is basically the area of that net, that two-dimensional wrapping that goes on the outside of a three-dimensional figure. We're going to try to figure out how much area that net has. So, in more specific terms, surface area is the number of square units. It is a square, I say, because when you're talking about your area, you always put your units with a little power of 2 on them, or you square them, and that's what I'm talking about right here. And this is only on the exterior of the solid. So this would be like the cellophane or the shrink wrap that would go on the outside of a brand new cup. So the cup would have its own volume and area, and we were just talking about that, the outer cover or packaging that would go on there. So now let's talk about some general formulas for this. So now I am going to try my best to provide you with some good, clear formulas for the surface area of a prism and the surface area of a pyramid. But what is I think going to be best for you is if you understand the general concept that we're trying to complete here, and then once you have that, then you'll be in great shape. So in general, when I'm talking about surface area, there's a couple things that you're going to be interested in, which is going to be the bases, which you will find at the top and the bottom of a figure, or maybe at the front or back. And then there's also going to be the lateral surfaces. Now the lateral surfaces are going to be these faces that are going to be around the middle. They're not going to be a top or a bottom. They're not going to be a base that's at the front or at the back, but they're going to be these ones that are around the figure as well. So if you can find the area of the top base and the area of the bottom base, and you can also find the area of those lateral surfaces, what you're going to figure out is the surface area. So this is very general, and the reason why it is so general is because you can have lots of different prisms. You can have nice square prisms or triangular prisms or hexagonal prisms, and that means a different kind of formula is used for each of those shapes. If I give you a general rule, then this will always work. If I give you specific formulas, I'm going to have to give you like 13 of them, and then that will be very, very confusing to try to memorize 13 formulas, and so that's just never going to work. So let's just try to keep it a little bit more general. So let's start off with cubes. So now cubes are fantastic, and they're so fantastic because they're so strict. Each side of a cube has the exact same length, which is amazing and wonderful and also a bit rare. I'm going to say that the side length here is S. So now my basic technique that I was talking to you about was I was talking to you about how surface area was a base plus another base and then plus the lateral area. There's your general technique. So now let's see if we can boil this down a little bit. So now surface area, if we want to take that further, you might notice that there's two bases. And in a cube, like most prisms, the bases are going to be identical, which means that we can simplify this down to 2b. And then we can have the lateral area at the back. I want you to notice that I'm using a capital B here because I want that to represent something that you have to calculate. I want it to represent your base area. Next, let's take it and make it more specific for a cube. So now a cube with side length S, the area of that base right there, which is a square, is going to be S squared. So that means this is going to be 2S squared. Now for the lateral area. Now the lateral area is going to be a little bit interesting. What's going to happen here is that what I'm going to ask you to do to find your lateral area each time is I'm going to ask you to find the perimeter around the base. And then I'm going to ask you to multiply it by the height. Okay, so now let's take that and let's apply some cube-specific information to that. So for our cube, we know that the perimeter is going to be 1s and 2s's and 3 S's and 4 S's. So that means that I know that my perimeter right here is now 4 S's. And now let's talk about height. Height also on a cube happens to be S again. Now S squared right here is going to be looking great. And then finally, now we have 2s squared and we have 4 more s squared, and we are up to our final surface area formula for a cube, which is 6s squared. Now, I really do think that that's a great formula, and if you can memorize it, fantastic for you. But I'll be honest with you, every single year I teach this, I look it up. And that's because I don't remember that. What I do remember is I remember these general formulas. And you know what? They're very simple and easy to remember, and I've remembered them ever since I was a sophomore in high school, and they always work. They work for cubes, and they work for triangles, and they work for hexagons. They work for trapezoids and kites. And so that is something that I try to keep in my mind. I love this thing, and I hope that you like it too, but I really deeply feel passionate about these ones because they just work all the time. Let's take the same idea right here for this prism. So I'm going to try to be a bit more general about this one. If you take a look, I have not labeled the side links as clearly. Specifically, the base is just labeled with a big capital B. Surface area in general, once again, what I want you to do here is I want you to find the area of that base, and there'll be a base at the front and another one at the back, or maybe you see that as a top and a bottom. I'm not quite sure. But there are 2 of them, so you're going to find 2 of those areas. And then the next thing that I want you to do is I want you to measure the perimeter around that base. And I want you to multiply it by the height. So we're using the exact same techniques that we had with this cube, but we're just not going to make it any more specific. So that is going to be the guide that you're going to want to use. All right, now pyramids. Let's talk about that. So now pyramids are going to be interesting for 2 reasons. Pyramids are a little bit different because, one, there's only one base. There's a base at the bottom and there's no base at the top. So that means when we're calculating surface area, we're only interested in the one base. We don't need a second base. Second thing is the lateral faces. If you take a look at my square, this lateral faces that we had, the faces that were kind of around the middle, they were also squares. Or another way to say that is they were fancy rectangles. And even this guy, this one that has triangle bases, this one also has lateral surfaces that are, in fact, rectangles. So that's interesting. For a pyramid, though, the lateral surfaces are triangles, which means that when you're using a triangle, you need to remember some of the characteristics of a triangle. One of the major things that I want you to remember about triangles is that when you're calculating the area of a triangle, it's not base times height, it's 1/2 base times height. So we are going to need to incorporate this extra piece that we didn't see for prisms and we didn't see for cubes. Now the perimeter part is still very much the same. We do want to know that. We want to know the perimeter around the base right down here. And then what we would need to do is we would need to know the height of each of these triangles. Now the height of the triangles is not going to be the height of the pyramid. These triangles are on a bit of a slant. Their height is referred to as the slant height. And in this diagram, it is signified by a swoopy cursive L. So that is going to be height, but it is going to be the slant height. So that is going to be an important characteristic that you're going to need to make sure that you have. And once you have that guy right there, then you'll have everything that you need. So here are our basic formulas right there. Okay, let's see if we can put them to work. So for my first example, what I want to do is I want to name these solids, and then I want to find the surface area of them. So my first one, the major thing that you need to decide is you need to decide if it is a prism or a pyramid. This one has 2 bases that are triangular, and its lateral surfaces are rectangles, which means it's a prism. But more specific, the bases are triangular, and they're even right triangles. So the best name that you could possibly give to this guy would be right triangular prism. That is the most syllables that we can cram out of it. If you could simply identify it as a prism, that would be satisfactory. If you could say it's a triangular prism, that would be even better. But right triangular prism is going to be our best. Next, second one. Second one right here definitely only has one base, and the lateral surfaces are triangles, which makes it a pyramid this time. It is also a base that is square, so we could call this one a square pyramid. If you can just identify it as a pyramid, that's fine. Square pyramid is just a little bit better. All right, now let's do some calculation. So when I'm looking for surface area on here, what I want to do, once again, is I want to focus on the bases, and there are two of them. In this case, one at the front and one at the back. And then I also want to look at that lateral area, and we're going to get that by using the perimeter and the height. Okay, so now our base in this case right here is a triangular base. So that means that you need to make sure you know how to find the area of a triangle. So a triangle is going to be a specific formula, which is going to be 1/2 base times height of the triangle. I want you to notice I'm using a lowercase b right here because this is going to be the base of a 2D shape. It has nothing to do with the 3D shape. So now let's see if we can put this all to work. So now when I'm working inside the set of parentheses, I'm just focused on the triangle. So I am going to be using my 1/2, and my base is just the base of this two-dimensional triangle at the front here, which is 3. And my height is not the height of the entire shape, but rather the height of this triangle, which is going to be 1. So we're going to use that 1 right there. Okay, so that part is very straightforward and easy, and that works really nicely. Let's move on to perimeter. So now our perimeter right here is a bit of a trick. What the perimeter is referring to is the distance around the entire outer edge of this base that we've been talking about, this triangle. And that is easy to find as long as you know all of the side lengths. And we do know 2 of them, but we are also missing the 3rd. So we're actually going to need to do a bit of side work over here in order to get that 3rd side length. And then we can hop back into our surface area calculation. So let's do it. This guy right here, this base, is a right triangle, which means you can use all of your right triangle tricks, and you have a lot of them. So you have things like SOHCAHTOA, you have special right triangles, and you have the Pythagorean theorem. Pythagorean theorem is fantastic, and I'm going to bet that you're super great at it. So let's try the Pythagorean theorem. If I take the 1 and the 3 and I plug them in, specifically for A and B, I can figure out what the length of the longest hypotenuse is very quickly and easily. So there's my 1 squared plus 3 squared. C is always the hypotenuse, and that's what I'm solving for. I'm squaring my values and I'm adding them together. Now 10 is unreasonably large, and that's because it's the wrong answer. Remember that you do need to take the square root of this. Square root's not going to be very nice today, but that's okay. We'll just round it. That's going to be 3.16. Okay, let's label our drawing. And let's move on to our surface area calculation. So now that we've done that, now we can jump back into surface area. And if you remember, we were leaving off at perimeter. So perimeter is the entire distance around this triangular base, and that requires all of the side lengths. And now we have them. We know that we have a side length of 1, we have a side length of 3, and we have a side length of 3.16. There you go. There's your perimeter for your base. All right, now for the part that I think is trickiest and most important, and the reason why I'm giving you this exact example. Next, our very last piece that we have right here is height, and when I say height this time, I'm referring to the height of the entire 3D figure, and more specifically, when I say height, I am referring to the distance between your first base and your second base. Now in this particular drawing, the way that it's drawn, our base is at the front and are at the back, which means that the height is not actually a vertical height, but rather a horizontal height. So if you were going to reach over here for your 1 again, because it's a vertical distance, that feels good, but it is wrong. The height that I am referring to is also working under the assumption that your prism is a vertical one. It is extending up and down, but that's not exactly what's happening here. This one is extending forwards and backwards. So that means that our height is not the 1 again, but rather it is the distance between the front base and the back base. It is a distance of 2. So this is going to be a little bit of a trick right there. Okay, so now that is your entire formula. Everything is filled in. All you need to do now is calculate. Now, unfortunately, this is also a problem for some students because they forget their good old order of operations. Remember that when you're working on calculations like this, you want to work your way through the order of operations starting with parentheses. So we've got a couple of sets of parentheses that we need to work on first. So I'm going to work on this guy right here. and that's going to give me 1.5. And I also have this set of parentheses right here, and I'm going to get 7.16. Next, make sure you're moving on to multiplication next. So now we are multiplying here 2 times 1.5, which is going to give us 3. And we are multiplying here 7.16 times 2, and that is going to give us 14.32. And even though this addition sign was, third in line right here, it is going to be the very last thing that we do because of the order of operations. So we're being very careful with our order of operations. We're not changing the order at all. We're just not working from left to right blindly and because we like it. We are following our order of operations very, very carefully to make sure we get the correct answer. And once you have the correct answer, you want to make sure you have the correct units as well. Not just feet, because we're doing area right here. It is going to be feet squared. Pyramid. Next one is a pyramid right here. And so for our pyramid, what we want to do is we want to go through the same kind of situation. So now what you want to do here is you're going to want to find the surface area of your base. Now this time we only have one base, so we're going to be only using a one big capital B, not 2B like last time. Then what you want to do to that is you want to add on the perimeter, and you're going to multiply that perimeter by the slant height. Finally, don't forget that these lateral surfaces that we're talking about when we're talking about perimeter and slant height, they are actually triangular, which means you need to remember that just like last time when we were working on triangles, that 1/2 has got to be in there. So we're going to make sure that we include that 1/2 right there. So the pyramid formula is different because it only has one base and it has the 1/2. So it's shrunken down each time. Okay, so now let's see if we can do it. So now our base right here, our base is actually a big fat square, which is really, really easy to work with. So our surface area is going to be super easy to calculate. It's going to be 40 squared. Next, perimeter. Perimeter of this guy is going to be great as well. Because it's a square, your perimeter is going to be a 40 and a 40 and a 40 and another 40. There's going to be 4 40s that are going to make up our perimeter. And lastly, slant height. So now slant height is the trick on this problem. So slant height is going to be this dimension right here. And if you notice, it's not given to you. What they do give you is this dimension right here, which is the true height or the altitude of the pyramid. And that's fantastic information, and you would really love to have that in a different lesson. But for this lesson, that's not going to be very helpful for us because it's in the middle of our figure, and we're only interested in the surface. So that means, once again, we're going to need to do a little bit of side work in order to get one of our dimensions. Get used to this idea of completing side work. These problems tend to be a bit tricky, so you need to make sure you can cover all of those dimensions, even if they're not given to you directly. Okay, so take a look at what we've got right here. I've already highlighted 2 sides, and I want you to notice that they are part of a connected figure. This height that was given to us, 47, and this slant height right here are part of a right triangle that is formed in the middle of our pyramid. This triangle is not on the outer surfaces right here. This triangle extends from the very center of our pyramid across the base and then up the side of it. So that guy right there is a right triangle. And if we could just figure out the hypotenuse of that right triangle, it would be great. Now, as it sits right now, we don't have enough information to find out what the hypotenuse is, so we're going to have to dig for another piece. And that is where a little bit of ingenuity comes into play. Because this true height extends down to the center of our figure, that means that it is also going to count as the midpoint of our side length right here. So this little edge right here is going to be the same as the length of half of our full side length. That edge right there is 20. Now we have 2 dimensions, and we are missing a third, and we're perfectly set up for another round of Pythagorean theorem. That we are looking for the hypotenuse, so our 47 and our 20 are going to go in for A and for B. And C squared is the one that we're going to be solving for. So we're going to have our 47 squared first, and our 20 squared second, and then our variable or unknown C squared last. 47 squared is huge. And 20 squared is pretty large, but a lot easier to come up with. We're going to add our values together, 2,609, and that is definitely too large. It doesn't make any sense that the slant height would be so big, and that's because you have to take the square root. So we're going to square root this one, and we're going to end up with 51.08. Our slant height in our picture right here is 51.08. Great. Let's put that into our formula. So that is going to be our slant height. That's going to go at the back right here, 51.08. Now we have everything collected in our surface area formula that we need, and we're going to start calculating. So let's do it. So first round right there, 40 squared is going to be 1,600. Over here on the other side of the plus sign, we're going to skip the plus sign for right now and follow our order of operations. All of this is multiplication, so by all means, feel free to type it all into your calculator. I'm going to use 0.5 for my 1/2. I'm going to use my 4, and I'm going to multiply that by 40, and I'm going to multiply by 51.08. So this is all multiplication, 1/2 times 4 times 40 times 51. And so we're going to multiply all of that together, and we're going to get a very big number, which is going to be 4,086.4. Fantastic. Now what we can do is we can add these two pieces together, and when we add them up, we're going to get our final answer. And our final answer is going to be 5,686.4. Don't forget your units, and don't forget to square your units. Backside. Last example for surface area that we're going to do right here, or last examples I should say that we're going to do right here. What we have is we've got a couple of trickier ones. And so we're going to take a look at these guys next. So this one right here is going to be a surface that is particularly tricky because it's actually a composite. This is actually two different prisms that have been smushed together. It looks like a house. So in the bottom portion of our house right here, what we have is we have a very nice rectangular prism, which would be easy to work with. So we're going to be including that as part of our calculation. But then, on top of it, we have this triangular prism as well, and so we want to make sure that we include some work for that guy as well. So let's break up our work into two different pieces. So we are going to have our triangle that is going to be a prism, but then we're also going to be adding on to that some surface area for our rectangle. And so we're going to be having to calculate two surface areas, and we're going to simply add them together. Now that is not all of it, though. So let's think about one last thing. Let's talk about the place where they meet. So where the rectangular prism and the triangular prism meet is actually a shape that is a rectangle in shape. And this rectangle is shared by the two pieces. And because it's shared, that means that it's no longer on the outer surface. It's not part of the surface area anymore. So this triangle prism right here has no bottom. There is no bottom on this triangular prism at all. It is only a front and a back and the two top pieces. This rectangle right here has no top. So it is a front and a back and a left and a right and a bottom, but there is no top to that guy right there. So you have to be extra careful that you don't include any extra pieces that you may have thought existed but no longer do. So that is a big trick right there and something you have to watch out for. Okay, so let's talk about it. So for our first prism right here, when we calculate our surface area for this guy, what we're going to do is we are going to be talking about our bases being the very front and the very back. So this one does have two bases. Even though it doesn't have a bottom, it has two bases. And then what we're going to do is we're going to add on our perimeter, but not the entire perimeter, because we're going to be removing the bottom portion right there. So it's going to be a kind of a shortened perimeter right there. And then we're going to multiply it by the height. And once again, like we saw on the front side, the height is actually going to extend not from the bottom to the top, but rather from one base at the front to one base at the back. So that is going to be our surface area formula for this guy. Now for this one over here, what you can do is you can think about this one slightly differently or the same. You can think about it as a rectangle that has been extended to the back, very similar to our triangle, or probably more likely what's going to happen is you're going to think about it as a rectangle at the bottom that has been extended up. And if you think about it that way, then you're going to need to think about this surface area a little bit differently. Now, if you think about it as a rectangle that's at the bottom and extended up, it is going to have a base at the bottom, but there will be no base at the top at all. So this will only have one base, and then it will have a perimeter that is multiplied by the height. And this time what I would do is I would treat the height as the actual vertical height. Once we've calculated the surface areas for both of these, then we're going to add them together and we'll be done. So let's see if we can do that. So going back to the triangular prism. So for the triangular prism, because its base is a triangle, we need to make sure that we are going to be using the formula for triangle, which is going to be 1/2 base times height. Okay, so now let's see if we can fill in some of these numbers. So our base for just our triangle, our two-dimensional shape, that would be this distance right here. Now, it's not very clearly labeled, so the first thing you might think is, oh, I need to use Pythagorean theorem to get it. Not a good choice. Don't use the Pythagorean theorem because you can use this guy. This 21 yards right here is going to be repeated a second time. So we are just going to be able to use a base of 21. Now, height of this. Height is very easy, and they gave it to us, which is great. If you take a look right here, they mention that the height of this triangle right here is 10 yards. So we don't have to reach for that one or calculate. We're good to go. Next, perimeter. Now, for the perimeter, please remember that what you want to do is we're focusing on lateral surfaces. We're focusing on this rectangle right here and the other one that was going to be back over there, but we don't want to use the bottom one. So when we're talking about the perimeter this time, we're only going to be using two sides. We don't want to use this bottom side because that's where it meets the rectangle. So we're going to be using the 13 and we're going to use the 16. All right, now height, once again, another trick. For your height, once again, this is going to be the distance from the base to the other base. So not from the bottom of the triangle to the top, but from one base to the other. So that is going to be a distance of not 10, but the distance from our base to our base right here should be listed along this edge. And even though there is no number listed along the edge, we can use the one down here in order to help us out. This edge should be listed with an 18, and our height should be an 18 as well. Okay, so now that is everything we need for our triangular pyramid. If we start sticking those things together with a little bit of addition and subtraction and multiplication, what we're going to do is we're going to end up with a really great answer. I'm going to tag these two pieces together and I'm going to get 732. Okay, so now that is going to be our final information that we need for our triangular prism, but we still have got a rectangle that is attached to the bottom, so let's work on that next. So now, with our rectangle right here, the rectangle was interesting because it does not have a top. The top of this rectangle would be open, and it's waiting for the roof to be set on top of it. So let's talk about our base. I'm going to treat the base as if it was the very bottom of our rectangle right here. So I'm going to use this area, these two values to calculate area. Then, for my perimeter, I'm going to use the entire perimeter of my bottom base right there, which is going to be a couple of 21s and a couple of 18s. So it's going to be two 21s and two 18s. Okay? And then finally, the height. So the height in this case is going to be the actual vertical height. And so our vertical height right here is listed over here on the far left side, and it is 6. Now, this is the only trick for this one was, once again, it didn't have two bases. It only has one base. So if we start doing some calculations for this one, we're going to end up with 378 for the base. And then we're going to end up with 1,248 for the lateral surfaces. And that is going to give us a added total of 1,626. Okay, so now this is all of the information from the triangular prism, and this is all of the information from the rectangular prism, and now it is time to add them all together. So to add the roof to the house, we are going to just use a little addition, and when we use that addition, we're going to end up with a grand total of 2,358 yards squared. This is not a more difficult problem, but it is certainly a lengthy one. The trickiest part right here is remembering that some of the things that usually are surfaces, like the bottom of this triangle and the top of that square, are gone now. And so you need to make sure that you remove those. And then you can add all the bits together. Here's another tricky problem. This problem right here is tricky because they're actually going to give you the surface area. So this surface area right here is given to us. It's 1600. And it's a pyramid. So what we're going to try to do is we're going to try to use that given surface area to figure out what the slant height is. Now, we don't have enough information to use Pythagorean theorem or SOHCAHTOA to find our slant height like we did last year. So we're actually going to use the surface area formula. So let's see if we can take this surface area formula for a pyramid and fill in as much as we can. So let's start with the surface area itself. We know that the surface area is 1600, so I'm going to replace my SA right here with 1600. Now the base. Base is very easy. It is a square base, which means that the area of that base is going to be 20 squared. There is only one base, so we don't need to double this. We're just going to do 20 squared. The square base also makes the perimeter extremely easy to get. Perimeter is going to be a 20, a 20, a 20, and another 20, or 4 times 20. And it is the slant height, which is the thing that we are solving for. So our variable is going to go at the very back right here. Now we have a lot of numbers and only one unknown, so we should be able to solve this pretty easily. Let's see if we can simplify. So we've got 20 squared right here, which is going to give us 400. Then we've also got our 1/2 times our 4 times another 20, which is going to give us 40. And that 40 is going to have an x next to it. Now, all of a sudden, what we have is we have an equation that I would give to some middle schoolers, and they would be able to solve this very quickly and easily. So we're going to move our 400 over to the other side by subtracting it. Everything turns into an algebra problem. And then we're going to get rid of our 40, and we're not going to subtract or add it again. We're going to divide it this time. We're going to divide by 40 each time. And that's going to give us our slant height. The only variable that we have left is our slant height, and it turns out that our slant height is 30. Now this is an interesting thing. You always want to make sure you include your units, and we've been doing a lot of units squared, but this time we did not solve for a surface area. We just solved for a height, and so we are going to leave it as millimeters, and we are not going to square it this time. All right, last one is a U-try problem. So what I'd like you to try to do right here is I'd like you to try to see if you can calculate the surface area for this guy. It has a regular hexagon for a base right there, so you might need to remember what the formula is for that. Let me give you a little bit of a hint. Surface area is equal to the base times 1/2 the perimeter times the slant height. And for that base right here, don't forget that the hexagon has got an area formula of 1/2 the apothem times the perimeter. Okay, pause your video and see if you can calculate the surface area for this one, and then I will share my answer with you. Here is the answer to our question. Our apothem is going to be our 4√3. So we've got that plugged in. Our perimeter is including 6 sides that all have a length of 8, and we're going to use that twice. We use that once for the actual area of the base, and then we use it once again for the lateral surfaces. Our slant height is going to be the 18 that is labeled very clearly for us, and so we've got that right here at the back. I calculate all of this multiplication, and I calculate all of this multiplication. Then I'm going to add these two pieces together, and that gives me my surface area. I want you to notice that the surface area is squared because it is a surface area. It's not a length this time. Okay, if you have any questions, please reach out to your geometry teacher, and please join the Zoom so that you can get those questions answered very quickly and easily. Thank you so much.